2 years ago, when I used to play Dead Cells on my Arch Linux setup, I often wished there was a no-fuss, copy-and-run way of playing my games. You see, nerds like us like to play our Windows games on Linux using a compatibility layer known as Wine. Now, one thing that struck out to me was how Wine isolates all the resources, like the system files, the libraries, and game assets, into one single directory for a specific game. This is known as a Wine prefix. My gripe with the aforementioned technique is that once you start playing the game, the clean installation gets tainted with your progress. To create a checkpoint, one must choose between either copying the entire Wine prefix or manually finding progress-related files. Now, this is an inconvenience, especially when we're switching machines. It forced me to lose all my progress and rerun the setup every time I picked up an old game. Ideally, I'd want the fresh Wine prefix on an external storage medium, along with a list of saved game states, of which I can pick one to resume. If the progress made in the current run is good, I save it as a checkpoint. Otherwise, I nuke it and revert to the old Wine prefix. Whichever be the case, I don't have to copy and rerun the setups. Now, while this might sound like a problem that can be solved using a version control system like Git, the initial commit to track all the files in a Wine prefix will need to compress and calculate the SHA-256 sums of all the objects. And even beefy computers will choke at such a computationally intensive task. If you've ever worked with a large Git repository, you know how annoying it gets to do simple Git operations. So then, how can we create a layer of separation between this freshly installed game and our progress? Well, let's start by defining our problem a bit more concretely. We want to have a read-only version of the game assets and a writable layer on top to capture the changes while the game is running. For those in the audience who have worked with cloud infrastructure, this idea might sound strikingly similar to containers. To oversimplify, containers are a bunch of unshared calls to the Linux kernel to fake a different environment by unsharing namespaces such as the mount, the process ID, or the network namespace. The observation to make here is that when we run a container from an image like Alpine, we get access to a fully hierarchical file system that allows file modifications. Upon removing and restarting the container, however, these modifications are wiped clean, yielding the clean setup as defined in the image. Docker, the most popular container engine, employs something known as the overlay file system to create this layer for us to work with until the container gets destroyed. An overlay file system consists of a read-only lower directory, a writable upper directory, and a scratch working directory to keep track of changed objects. All of these get combined into a merged directory during runtime. Sounds an awful lot like our problem definition, doesn't it? Well, let's put that idea to the test. First, we create the upper and the work directory using the makedir command. We rename the Wine prefix to be the lower directory. And finally, we run the mount command with the file system type overlay to layer all of these into one merged target. But of course, the command fails. We need superuser privileges for the mount operation. While we could use the sudo command here, elevating our privileges to the superuser root just to play a game feels like an overkill. Besides, running commands as the superuser opens us up to unnecessary security risks. And as far as I can tell, there's no way of mounting vanilla overlayfs in the user space. 2 years ago, this is where I would have ended this video. But let's take a step back. Docker isn't the only containerization engine. Podman, a drop-in replacement for Docker, is able to run rootless user space containers without needing a privileged daemon process running in the background. At this point, the keen listeners amongst you might have the same question that I did. If Podman can run rootless containers, how does it mount an overlay? This is where I'd have to introduce you to a feature of the Linux kernel known as File Systems in the User Space, or FUSE. It's an interface allowing secure, non-privileged mounts. Specifically, Podman achieves user space overlays using something known as Fuse Overlay FS. There's also a convenient command line tool with the same name that we can use to mount our own overlays. So let's give this a try. We will run fuse overlay fs with the same options as the previous mount command. And that merges the directories. Under the hood, the fuse overlay fs handler reads all the directories as layers along with any user ID and group ID mappings. It creates a directory called work inside the work directory we specified. And all of these layers are used to create a fuse session, which passes the read and write system calls to the respective layers. Running the game from the merged directory causes any new file changes to get accumulated in the upper directory. Once we're done playing for the day, we can unmount this upper directory using the fuser mount command. Honestly, I don't know if it's called fuser mount or fuser mount. It's a personal preference, I suppose. Before I leave, one idea that came across my mind while writing the script for this video was whether we could create a less computationally intensive version of Git at the cost of disk usage. Big thank you to Grant Sanderson, better known as 3Blue1Brown, for his animation library which was used to animate this video, and thank you for watching till the end. I hope you learned something. I will see you around.